Here is your Proving Trig Identities quiz. The order of your questions may be different than this one, so just FYI, my number one may not be your number one. So, when we're proving, we want to start by working with the side that looks more complicated. So I would definitely say that the left-hand side looks more complicated, so this is my goal. And remember, just because you can substitute something doesn't mean that you should. So you want to start off with baby steps and just a little bit at a time. I would prefer for my denominator not to have more than one term in it. So when I look at my chart, 1 minus tangent squared is secant squared. And since there's a secant squared in the numerator, I don't think I want to change the numerator. So this is 1 plus secant squared x, you have to have the variable, over secant squared x. Some of you are leaving these off. That makes it wrong. You can't just have secant of nothing. Also, these are equations, so this equals 1 plus cosine squared x. You have to continue this on. So then, on the left-hand side, I would say I could split my fraction. So this is going to be 1 over secant squared x plus secant squared x over secant squared x. And that equals 1 plus cosine squared x. Well, 1 over secant squared is cosine squared. This would be plus 1 equals 1 plus cosine squared x. Still not quite finished because I got to flip that around. So that'll give me 1 plus cosine squared x equals 1 plus cosine squared x. And there you go. Number 2. All right, so I would definitely say the left-hand side looks more complicated, so this is my goal. So I need to multiply those two binomials together. I'm not going to do any of my ratios or my quotients or my reciprocals until I've multiplied. There's no reason to make it more difficult than it is. So when I multiply these binomials, I have to multiply sine theta by tangent and secant. So this will give me sine theta, tangent theta, then minus sine theta, secant theta. Then I have to multiply 1 by each one of those. So that'd be plus tangent theta minus secant theta equals negative cosine theta. Because again, there is an equal sign there, and you have to have the thetas in there. And don't go changing it to a different one along the way. Okay, so got a lot going on the left-hand side. I think I want to look at my reciprocals and my quotients. So this is going to be sine theta times sine theta over cosine theta minus sine theta over, so secant is 1 over cosine theta, plus tangent is sine theta over cosine theta, minus 1 over cosine theta, equals negative cosine theta. Okay, so here, when I multiply this is going to be sine squared. So this is going to give me sine squared theta over cosine theta. Then I have negative sine theta over cosine theta plus sine theta over cosine theta, so those zero out. And then minus 1 over cosine theta equals negative cosine theta. All right, so sine squared minus 1, I can make this all into one fraction, so sine squared theta minus 1 over cosine theta equals negative cosine theta. I could have actually kind of combined that step, but I didn't. So then here, if you look on your chart, sine squared theta minus 1 is not cosine squared theta. It would have to be 1 minus sine squared. So to make that happen, I'm going to factor out a negative. Then those will flip around and get 1 minus sine squared theta over cosine theta equals negative cosine theta. So then I can substitute cosine squared. So negative cosine squared theta over cosine theta equals negative cosine theta. Then this cancels out with one of those, and negative cosine theta equals negative cosine theta. check mark up here. There we go. All right, let's look at number 3. Sine alpha over 1 minus cosine alpha minus cotangent alpha equals cosecant alpha. Okay, and these are alphas. These are not lowercase a's. Okay, it's written like this. I cannot do it, but that's how it's done. It's like a fat Jesus fish. All right, so I think I want to work with the left-hand side. So when I do that, I'm going to make this into the quotient. So sine alpha over 1 minus cosine alpha minus cosine alpha over sine alpha equals cosecant alpha. So now I need to get a common denominator. So this first one, I'm going to have to multiply by sine over sine. So this will be sine squared alpha. This one I'd have to multiply by 1 minus cosine alpha over 1 minus cosine alpha. This will be minus cosine alpha times 1 minus cosine alpha. So then my common denominator is 1 minus cosine alpha times sine alpha. That's equal to cosecant alpha. Okay, so in the numerator, I'm going to distribute this. So I'm going to get sine squared alpha minus cosine alpha plus cosine squared alpha all over, I'm not going to distribute this yet, 1 minus cosine alpha times sine alpha. And that's equal to cosecant alpha. All right, so then in the numerator, sine squared alpha plus cosine squared alpha is 1. So I get 1 minus cosine alpha over 1 minus cosine alpha times sine alpha equals cosecant alpha. So these two cancel out. That leaves me with 1 over sine alpha is equal to cosecant alpha. So cosecant alpha equals cosecant alpha, and we are done. Some of you, I think, are trying to make things way too complicated. Some of you are also making up math, and you are splitting fractions in weird ways that shouldn't be split. You can only split them if your numerator has a plus or minus in it. So for instance, here, I could split this into 3 fractions. They'd all have this denominator, and this would be 1, 2, 3 different numerators. I mean, I wouldn't want to do that here. I'm just saying that's the only way you can split them. Some y'all are trying to split them with multiplication and doing some other weird things. Remember, your algebra steps are exactly the same as they always have been and always will be. So don't be making up math.